So far we've discussed the types of data we can use, and we've also talked about how to name that data. But the third and final piece to define a variable is the value. So what we need to do is discuss how a computer really represents those values. Now, if a computer has a certain set of memory, and usually when we visualize computer memory, we visualize it kind of like a stack. And this stack represents a stack of all these little buckets. And each one of these buckets holds data. Now, how much data, what kind of data, that's what really matters here. So we know we have our five types of data. We have our int, we have our double, we have our byte, we have our string, and we have our bool. And as I mentioned before, each one of those pieces of information requires a certain different amount of space inside of storage, inside of the hard drive. So what that means is that we got to be careful about what we try and store in what. So each one, as I said before, each one of these buckets each one of these containers really represents one of our variables. So whenever we create a new variable, not only are we specifying the type, when we specify the type, what it does is it comes over to the memory and it says I need to reserve a certain amount of space. So for example, an integer might reserve 2 containers worth of space. This is just hypothetical and relatively speaking in terms of the other variables. But once it's actually reserved that space, it needs to be given a name. Think of it kind of like a parking space. You're reserving a parking space, but you want to reserve that parking space with your name on it. So it might be, say for example, something like user age. So we've created a variable called user age, and we've now defined and reserved those 2 top spaces for that variable. So for example, if we try to do something like let's say a byte, and it might be something simple like, I don't know, day. It might represent like the day of the week or something like that in terms of 1 through 31 or something like that. And a byte might only take up 1 container of storage space. Now, what could happen though is if we try and store something that doesn't fit, we could run into errors. So for example, if I tried to store Bob inside of the byte location, I'm going to get an error. And the reason why I'm going to get an error is because all the amount of memory that's required to store Bob doesn't match the amount of memory that Day has set up. So here's the gist of it. The gist is quite simple. You must store a value that matches the same type as the bucket you created. So for example, if you created an integer variable, you can only store integer values in that bucket. If not, what's going to happen is you're going to end up with the problem of a square peg and a round hole. It won't fit. No matter how you turn it, no matter how you manipulate it, it won't fit. If you try and make it fit, you're going to get an error. So you always must match the values with the types.